Just even though it's not even due until Friday, we started it just to kind of give us a little bit of idea because we started talking about, again, naming ionic and covalent bonding. Now, I just want to give a quick heads up as a reminder. Don't forget, ionic compounds are going to be a metal and a non-metal, but it could be a polyatomic and a polyatomic. It could be a transition metal and a polyatomic. It could be a metal and a, I don't know what else, another something else, right? But either way, they are ions. And what ions do is they give up and they accept and take electrons. Now, covalent bonds, just as a quick reminder, are going to be nonmetals and nonmetals that are bonded together. One more time. Covalent bonds are nonmetals and nonmetals that are bonded together. Now, from those covalent bonds, they do not give and take electrons. What they do with those electrons is they share. Now, from our notes, we didn't get to, verbally say this out loud. You had to read it a little bit. But at the end of our last unit notes, they talked about ionic covalent bonds. Now, an ionic covalent bonds, which is kind of like a jumbo shrimp, right? It doesn't make sense. Are you a shrimp or are you jumbo size? Well, ionic covalent bonds are whenever they share, but they share unequally. It was kind of like I gave the example. You have a dessert, a cookie, or whatever it is, and you want to share it with your sibling. You kind of break it a little bit uneven. That way they get a smaller piece and you get the larger piece. Kind of like H2O. The oxygen is stronger than the hydrogen, and it absorbs more of those electrons when they're sharing. It pulls it towards it a little bit more, and because of that, rather than it be a linear, H2O is a bent compound. Alrighty, so either way, there goes a review from a little bit of last unit and this unit. Now let's talk about this. We have, let me go ahead and move this out of the way so I can write a little bit easier. We've got naming over here, and when we look at our naming, and this is homework number 1 for unit 4, let's just go ahead and let's look at this one over here, hydrogen monoxide. Now, as a quick reminder, ionic and covalent bonds. Is it ionic or is it covalent?
Iodide.
Oh, iodide. I keep on messing that up, don't I? The iodide. Even earlier on this week on Monday. So hydrogen monoiodide. I don't know why I keep messing that up. Covalent or ionic, Mr. Acosta? Covalent bonds. And the other thing with covalent, which is a nonmetal and a nonmetal, is that on covalent bonding, we use prefixes, except we do not use, Daniel, which prefix do we not use on the first name?
Mono.
The mono. Right, we just leave the name as is. For an example, hydrogen. So that's an indication that's only one hydrogen. Mono means one as well. Iodine, which they have the root word, and then "ide" finishes it off. So in this situation, it should look like H-I. Tell me if I'm wrong, but there we go. One H and one I. Am I wrong? I didn't say iodine again. Did I screw it up? Oh, okay, I thought I screwed that up. Number 7, again, we're going through our homework to kind of help us out a little bit more before it's due this Friday. Iodine, right? And then pentafluoride. This must be a covalent bond because ionic bonds do not have prefixes. We talked about that on Monday, right? And iodine is a nonmetal, and then fluoride is a nonmetal as well. Now, iodine is written just the name, no prefix in front of it. That means there must be only one, and you are going to write that one first. Penta, oh, what number is penta? 5. F5. There we go. Remember, we went, did I mess up?
No, I was going to ask. So
Yes, sir.
For our final test, for our test for this unit, should we know all the penta?
Yes. And what Daniel's saying is, do we kind of have to memorize this chart from our notes? You do. You do. Yes, this chart. I don't believe in note cards, and not that I don't believe in them. It's just that me personally, I don't learn from note cards. This might be a note card situation where you make the note cards today, and sometime later on this afternoon, or if you see somebody in this class tomorrow, you need to just pop them to the side and quiz them. Quiz them, literally quiz them, just out of the blue. Just, here you go, throw a quiz out there. And then the next time, hopefully they quiz you. You know what I mean? We do have to memorize it. Let's keep going. I'm going to just go ahead and go down to number 8. Nitrogen, because that's how we name covalent bonds. Covalent bonds is going to have a prefix for the first name, except mono, and then you give the full name afterwards. The second word is going to have a prefix including mono. This one says tri. Then you have the root word, ox, and then you end in an ide. All of them end in an ide. Why? I don't know, whoever came up with this one. But dinitrogen, so that means 2 nitrogen, trioxide, 3 oxygens. Okay? And so that's what we did on Monday. Now, let's go ahead, and I'm going to scroll down to the bottom because we really are getting through some of this homework for you. Number 25. Remember, we also did number 25, which is O2. There are 7 diatomics. The diatomics means that they exist together. They mean that, or a diatomic cannot exist by itself. And oxygen, he's just too sad and depressed, I guess. I don't know. He's got to have his buddy. And so they're always together. They're just BFFs, I guess. They're happier together. And they just never exist by themselves. And so you will never just see an oxygen. Now, an oxygen will either bond with another oxygen or it will bond with something else, like up here on number 24. Now, we also talked about, well, this is a covalent bond, even though it's a diatomic. And when it comes to diatomic covalent bonds, which are like number 25, we just name the element as is. You do not use a prefix di or anything like that, and do not use the ide. Just as a quick reminder. But look at number 26. I have magnesium and I have nitrogen. Magnesium has a 3 and nitrogen has a 2. But I'm going to pause real quick.
Metal.
That is a metal. And so what kind of bond is it then, Daniel?
It's
It's
ionic.
ionic
So it
bonds.
makes potassium.
Magnesium?
Yeah, that would be
Magnesium?
Oh, magnesium. Sorry.
Uh-huh.
I think that it was
Would it be trimagnesium?
Oh, wait a minute. It's ionic bond because it's a metal. Do ionic bonds have prefixes?
Oh.
No. Yep. They do not have prefixes, so we're going to ignore that. Now, why do ionic bonds do not have prefixes? Because if I had for an example, a 2 and a 2, what would it do? It would cancel each other out and it would reduce. And because of reducing, I cannot do a prefix because if it canceled out and it looked like that, I didn't know that there was actually a 2 and it would have been a di. Does that make sense? So because I didn't know that, because that reduced is the reason why we do not use prefixes. So over here, magnesium, when we name ionic bonds, the first name is always going to be named as is. Magnesium. Remember, we still do not use a prefix, but what we are going to do is we're going to use the root word of the nitrogen, which is nitride. IDE. It still ends in an IDE, which is kind of helpful. Okay? Now, I'm going to just turn the page because I don't know what's on the back side. I just want to take a look real quick. Okay, so homework number 1, which is a video. Homework number 1, which is a video. Okay, so go ahead and watch those videos, fill in those words. I'm not going to go over those or do those with you because you can pause it and answer that. Homework number 2 is naming and writing the compounds. And then homework number 2, again, it looks like it's naming, which you should be able to do. And then homework 3 goes into writing the formulas. Okay, so let's go ahead. I'm going to move that out of the way. And I'm going to keep out, I need my periodic tables and my polyatomic charts because this is chemistry and I just need to memorize this. Believe it or not, some chemistry teachers make you memorize it because I just don't think we should have to do that. That's just too much. So, yeah, nuh-uh. I'm going to move my resources over here and I have my notes out. Here we go. So we started off with our notes just talking about naming covalent bonds, which we already kind of talked about. Yes, it is a fact. You do need to memorize those. Prefix only occurs with covalent bonds. Don't forget, a covalent bond is a nonmetal and a nonmetal bonded together. I suggest this would be a good note card situation, and then just quiz each other. That's just do it. Just quiz them. Oh, I don't want to take a quiz. Miss Munson said take a quiz. Force them. Put them inside the elevator and slam on that button. You know, like do whatever. You're gonna take a quiz. Okay, so do what you gotta do. And remember, let them know that you're doing it with love. You know, sometimes I sound aggressive, but deep down inside, and it might be really deep, there's still a speck of love there. Okay? Now, we have some rules with chemistry, and that's just part of chemistry. Remember, you do not use a prefix for the first word or the first element if it's a mono. That's a big no-no. Okay? And then we have this other one, which is really weird. What happens when you have two, it says here, vowels that are next to each other? It says drop the last vowel of the prefix word, like mono, that second O. You would drop that one and you would leave that other one there. So carbon monoxide, who in the world would have two O's, weirdo? No, you're going to drop one and just leave one, right? So either way, it really looks weird. It's really hard. It's a lot of practice. Some of it's just memorization. And don't forget, diatomic molecules, you just give the name. For example, H2 is just called hydrogen. Then we did some practice. Then we turned the page earlier this week and we went on to ionic bonds. Ionic bonds are a cation and an anion that bonds together. And what do? They donate and accept electrons. That's how they're bonded. Now with this though, we know the crisscross method. And we know that, for an example, the strontium is going to become a 1 and the chlorine or chloride is going to become a 2. Okay, because of the crisscross method. We also know that if it was a 2 and a 2, we would reduce it down to a 1. We reduce to its lowest form. And there you go, good call. And that's why we don't use those prefixes. Now, don't forget though, if you're using a transition metal, we need to go ahead and make sure that when we can crisscross back up, the F, what did the F originally have? And the F actually is an iron 3 because this 3 from the chlorine was crisscrossed up because it had to come down. And that's how we know that it's iron parentheses 3 chloride is how we actually name it. And that was a little weird, a little confusing. Let's go ahead and turn the page because here's where we're at. And then we're going to get into naming acids. And then after that, we'll get into practicing. And then we'll get into a reminder of moles. And there we go for today. So we got like a page and a half of notes, almost 2 pages. It says naming ionic compounds with things that are going to have polyatomics, because remember, they are also ions. They have charges. That's what an ion means. It says letter A, follow the same rules generally as you would do on the previous page. If the compound contains a polyatomic ion, simply name that ion, or just name the polyatomic. So hopefully that makes sense on why I broke out my polyatomics, polyatomic ions. So I'm going to leave this polyatomic chart right here in front of me. Letter C says, here's an example, NaOH. Na stands for sodium. OH is a polyatomic. This is a single identity. It comes together as is. And when we look at OH over here, it is hydroxide, or HO, I'm sorry. Where's it at? First part, thank you. OH, it was OH, sorry, and it's a -1 charge, hydroxide. And so that was the negative charge, the sodium is a positive charge. It says here, for an example, the OH is called hydroxide. Just name it sodium hydroxide. Done. Done. Name the polyatomic as is. But it says, for an example, what if it's a transition metal, which is copper, and it's going to be bonded with a polyatomic? Well, this copper or this polyatomic nitrate has a little 2. That means that the 2 came from the copper when I crisscross back up. So this is actually going to be named as copper 2 nitrate. Okay? So hopefully that makes sense because I crisscross backwards. So let's go ahead and practice this. First one is sodium, Na from the periodic table. It's a metal, and sodium Na is right here in group 1. It has a +1 charge. And then I have a polyatomic over here. My polyatomic, when I name it, is going to be sodium. You really don't need the +1. That was just me doing extra. Sodium, because we do not use prefixes. And then I'm just going to come over here and I'm going to find this C2H3O2. C2, first one, acetate. And we're just going to leave it as is. We're not going to change any of the ending to "ide." That's a big no-no. Name it as is, acetate, A-C-E-T-A-T-E. So
Sodium acetate?
that's it. Yes, sir. Absolutely. We do not change the ending to an "ide." No, no. All right, let's do it again. Number 2. Number 2 over here is calcium. It's also a metal. Again, I'm just being a little extra. It's in group 2. It has a +2 charge. This is just me, +2. Then I have ClO. Okay, ClO. Cl, chloride. Well, Cl is chloride, but ClO, wait a minute. Look, it has a little 3. So ClO3, chlorate. Woo, do not confuse it with chlorite. Chlorate. And I'm just going to name it as is. So calcium, chlorate. Do not change the ending to an "ide." No, no. All right. Oh, this one, let's go ahead and let's do this one. It's CO. CO is a metal, right? But cobalt. Cobalt. CO. Cobalt. But it's a special metal. Transition metal, CO. That means it has more than one charge. Transition metal, more than one charge? What's the charge? 2. Because you get this little 2 and you're going to crisscross back up. I agree with you 100%. Is it a +2 or a -2? +2, because all metals are positive charge. There we go. Perfect. So that means when I name it, yes, sir. Uh-huh.
It's probably yes, but is it possible to change like a metal from a cation from a cation?
Can I change it from a cation and make it an anion? Is that what your question is? No, that's a hard no. Metals are going to be cations no matter what. If you're my kid, you're a Munson. There is no ifs, ands, or buts. You're going to be a Munson. If you're a metal and you come from whatever family, whether you're the transition metal family or group 1 or group 2, you're a hard positive cation. You will never be an anion. Okay? You will never, ever, ever. I'm sorry. I was a little bit, whew. It almost like, kind of like, if you're a Munson kid, guarantee you're going to be at church on Sunday. There's no ifs, ands, or buts about it. Whoa. You can have your own opinion when you're over the age of 35 or 40. Till then, I'll think for you. Well, you could be over 45, but not mature enough to make your own opinion in my decision. And I get to make decisions for you if you're my own personal kids, even when you're 30s. me a number. Give a number.
Wait, what do you mean give a number?
Give a number. 4,
Give a
5,
number.
6, 7, 8, or 9. Say a number between those.
Number 4.
All right, so you're going to do number 4.
I'll do
Daniel, you got 5. And we're going to go down the list. Number 6, number 7, number 8, and number 9, Ben. No, you get to rest.
Okay, great.
Yeah, you get to rest. You look too cute to be, you know.
This must be nice. Okay.
Thank you.
I did not say you, Chris. Did not say you. You owe me a snack today, and not from over there. I want the barbecue snack. Next time you come in with your barbecue sandwich, I swear I'm gonna take the first
They're out
bite.
there today.
Are they?
Yeah.
No, don't, because you already aggravated them last time.
Dang.
Because he gets them cooking like at 8 a.m. and they're like,
That's
oh.
crazy. Makes them work too.
They're like, yeah, you make them work hard. All right, Mr. Acosta, you ready? Okay. All y'all got is 1, and he said it's easy cheesy. So, what's the answer for number 4? I'm not going to write it because I want to make sure it's correct. Go ahead. R-A. Say it again. Wrong. He's wrong. We're not going any further, Mr. Easy Cheesy. Remember, there's deep love. It might be a grain of salt love. No, Daniel, you do you.
Wait,
You've got number 5 to do.
Yeah, that looks correct to me. Hydroxide?
Uh-huh. So, okay, here we go. Oh, you see it now? Oh, he's about to change it.
Oh, yeah, that's why.
Oh,
The charred burger.
Yeah, focus on you do you, Acosta.
It has another one charge.
Do you give up? Do you want me to just give you the answer? Do you want me, do you sure? Do you want me to give you the answer?
Yeah, I see the answer.
What?
Wait, can I say it?
It's
I just
hydroxide.
Never give up. No.
Oh, how sweet over here. Wow, look at that love. Love is being shown from the other side of the room. Okay, say it out loud how you want me to write it perfectly. Now, nobody else write. I'll write. What do you tell me exactly what do I write? Go ahead. R. Whoa. Capital R.
Yeah, capital O.
Yeah, you better say it exactly. Capital R,
N.
lowercase a.
S. A.
Man, Miss Munson's practically doing all the work for you now.
O.
Capital O,
Capital H.
capital H, and it's wrong.
because you're from the parentheses. And
Well, why do I need a parentheses? Because RA is in group 2. Boom.
Yeah.
Woo! Look at her being nerdy. Nerdy. That's all right.
where's RA at? Is RA
It's all the way at the bottom. Look,
I can
it's
find
look
that one. I can read everything.
way down here. RA is in group 2.
Radium.
All right, Daniel, go ahead. What's your? Nobody else write. This is correct now.
Capital M, lowercase g, parentheses, capital C2, H3, O2, parentheses, 2.
Perfect.
I may have done the wrong one. Hold on.
Oh my God! So we're gonna skip number 6, and we're gonna jump to 7. Number 7. What do you want me to write?
Open parentheses,
Oh, whoa, weirdo.
N, capital N,
Capital N,
Capital H.
capital H.
4,
Uh-huh.
close parentheses,
Close parentheses.
3,
Okay.
capital P,
Uh-huh.
capital O.
Okay. Woo! That nerdy was right. This is a polyatomic ammonium. It's a polyatomic. Don't mix it with bleach. then phosphate, which is also a polyatomic. Polyatomic and polyatomic can bond together because they both have charges. Give it to me. Is number 6 ready?
Yeah.
Oh, okay.
Hold on right.
Okay. Fingers crossed.
That one's.
Go ahead. Capital N, lowercase a, 2.
2, O2. Am I wrong?
Yeah.
Yeah, you're wrong.
Thank you.
Just it's literally one digit you got wrong.
What did you? What am I missing?
Daniel, what's he missing?
What
Yeah,
am I
move the 2 over. Just one to.
Oh, whoa.
missing?
Okay, hold on. I'm going to pause because we're kind of all over the page. Sodium is a metal. Do we agree? Yes. And with that metal, it has a charge. What is the metal sodium's charge? +1.
I realized I.
Oh, wait.
Peroxide is not an element on the periodic table, but polyatomic, and it has a charge of -2. So the Na2 was correct, but what else do we put behind the O? Not a 2. The 1 crosses over, so we don't need parentheses. And you just told me that this is a polyatomic. That means it needs another element. OH is the polyatomic. So you were close. OH. OH. Peroxide.
Peroxide is O2.
Yeah,
Oh, whoa, peroxide?
It's on the.
Oh, so sorry. I take back everything I said about you out loud on the video and everything I even said in my head, which wasn't on the video. Whew.
Wait, so I was right?
You were right. Whew. But whoa. Do we still need parentheses? No, because that 1 crosses over.
So it could be Na2O.
Na2O.
Oh no, would just be NA or NaO.
Because the Na.
Because this 2 does cross over. This 2 does cross over. All right, number 8. Give it to me. Hg, which is good. Well, this 2 means that it has a +2 charge, and acetate, which is over here, has a what charge? -1 charge. I agree. And when we crisscross those over, this Hg doesn't have a number behind it, but this is a polyatomic, and the 2 is going to crisscross over, and so we need to have a what before we add that 2? Parentheses. So open parentheses, what goes in? O2, parentheses, 2. Ben, give it to me. I agree. Done. That was easy. Here we go. So we got through this torture. Not bad. Not bad. Now let's get through the next torture. This one's going to hurt a little bit, okay? So some of you put on your extra layer of tough skin that you have in your backpack. And let's go ahead. Okay, do not cry in class. Don't show your tears in here, okay? Hold it back. All right, here we go. We're going to name acids, okay? It says here, acids are compounds where hydrogen comes first. Hydrogen comes first. No ifs, ands, or buts. Accept it. You don't like it? I don't care how you feel about it. It has a hydrogen first. Okay? Now that you took it in, it says we've got a couple of things that we need to know. Acids, which are a compound that produce hydrogen ions in a solution, meaning that when an acid is put into a solution, the hydrogen breaks off of the acid. Okay, that's what happens when an acid is bonded with something or put into a solution. A solution, though, is a liquid, not a solid. So if you want to pour acid onto a solid, that's not what we're talking about. We're talking about pouring acid into another liquid. The hydrogen breaks off. Okay? Now it says, let's go ahead and let's start writing in our rules. All acids, we just said the main rule up here. Acids, oh, Miss Munson, you can't even spell. I deserve that laugh. All acids. Overcorrected and stuff. Let me go back with this. All acids. Oh, trauma's coming out. All acids start with a hydrogen. But now acids are broken into two groups. All right. The first group over here, which are called binary. Which is going to be a hydrogen plus an element. I think those are the easier ones. Binary acids are the easiest ones to me. They are hydrogen plus an element. But the other one are called ternary. And a ternary is going to be a hydrogen plus a poly. Okay? Those, I think, are a little bit more confusing. Now, when it comes to a binary acid, the way you write it is going to be hydro, then you're going to have the root of the element, and then it ends in an ick. So it's going to be hydro, the root of the element, and then it ends in an ick.
Oh, so like hydrochloric acid?
Yes! Oh, whoa.
Well, I didn't hear.
Okay. And then, what? Can you say it again, though?
Hydrochloric acid.
Oh, and then this is word 1, and word 2 is acid.
So you can have like H2O.
H2O
Hydrogen and oxygen.
is not an
So it has
acid.
to be one hydrogen.
Wait, then what about sulfuric acid? How does that work?
Sulfuric.
Yeah,
Acid.
that's a minus.
Yeah, but it doesn't start with
That's
hydrogen.
-2.
Sulfuric is that the sulfuric is not a element on the periodic table.
Sulfur?
Oh wait, no, I think we're bugging if
That's the next side over here. No.
So it's way, okay, yeah.
Okay. So ternary, which are hydrogen plus a poly. Now there's two types of ternary. It can be we're going to name it blank, and it's going to have an 8. This is the poly. The other 8 poly is going to have the first part of the poly, and it's an ite. So we change the poly. I'm just going to come over here, and I'm going to sit here, and I'm going to circle this, and that is the poly. So it's the poly is going to have its first part of the name, and it ends in 8, or the poly will be the first part of the name, and it ends in ite. I'm going to pause for a moment, and I'm going to come over here and show you. Acetate, 8, nitrite, ite. Do you see the poly ends in an 8, or the poly ends in an ite? Does that make sense? Now, okay, so we change the poly, and when we change the poly, we're going to leave the first part of the name as is, and the 8 becomes an ick. And then you name acid afterwards. If this poly ends in an ite, we're going to change, and we leave the first part of the poly alone. We change the ick to an us, and then you name acid at the end. But what I need us to know, and I'm going to write this in a different color, is that on ternary, okay, acids, all of them, all of them have no hydro. We don't add any hydro. So, if it is a hydrogen plus one element, then you're going to name it hydro, the root of the element, and then it. And then afterwards, the second word is acid that goes behind it at the end. Hydro, and your example was chloric acid. Now, if it's ternary, this is going to be a hydrogen plus a poly. But there's two types of polys. It's either going to be a poly that ends in an 8 or a poly that ends in an ite. If it ends in an 8, you change the 8 or the ending to an ick and then include the word acid. If the poly ends in an ite, we change the ite to an us and then end it in an acid. Okay? And hint, hint, there is no hydro. Now you probably see why I call binaries the easier ones. Alrighty. So, here we go. Practice time. So on our practice, we've got H3N. All right. In your head, you're deciding whether or not this is a binary with a hydrogen and element or a ternary with a hydrogen and a poly. And all I see is H3N. This is going to be a binary, one H, one element, we're done. No poly. Okay, so the binary, I'm going to first start off with the hydro. I'm going to look at the element. It is nitrogen, so I'm going to go with the root, nit, and I ended in an ick, hydronitric acid, yes. It just takes practice. It's a little weird. Okay. Number 2. Let's practice again. Now we're looking at number 2. In all acids, when you look at the formula, which is the letters, they all start with an H. And what happens is when you add that acid into a liquid, the H actually breaks apart. Okay? So this H right now is bonded to a polyatomic, NO2. Alrighty, so that means that no hydro. I'm going to come over here and I'm going to find NO2, and which one is it? Okay, and it ends in an ITE, and I'm going to change the ITE to OUS. So I'm going to NITRO. I'm going to pause, and then I'm going to OUS. Here goes the OUS. NITR, stop, change that ITE to OUS, and then end it with an acid at the end. Okay, number 3, binary or ternary? Ternary, because there is a polyatomic in it. So now that means no hydro. I go find NO3, which is right next to NO2, right? NO3. But this NO3 ends in an ATE. I'm going to come over here. I'm going to change the ATE to an ick. So let's go ahead and write this. NITR. I'm going to stop, change it to an ick, and end it in an acid. It's just going to be a hydrogen in an element. So what I'm going to do then, and I'm going to start with a hydro. Then after the hydro, I'm going to go find Br. Br is over here, and Br is a diatomic bromine. So I'm just going to have the root word, and after the root word, I'm going to end it with an ick, and then acid for the next word. So hydro, brome, ick, acid. Brome, instead of bromine, brome.
Looking at number 3 is just confusing.
Nitric acid? Okay. Does it make sense or no? Did Acosta help a little bit? NO3,
This is nitrate.
NO3, ATE,
Oh, never mind. So I was just misreading that.
ATE. Okay, no worries. It's just making sure that we all understand. Are we ready to go number 5? Okay, number 5 is not a binary, so no hydro. It's a ternary. And so I see hydrogen, and hydrogen has a 3 next to it. That's okay. It came from the polyatomic when it crossed over. All hydrogens have a charge too. What are they? +1. So there was a +1 that crisscrossed over, and that's why there's no parentheses. If that makes sense. So no hydro, but I need to go find PO3. I was talking long enough, I hope, so that way you found PO3 already and decided if it's an 8 or an ick. Is it an 8 or is it an it? I'm sorry, is it an 8 or an ite?
It is
8, ite. And it's going to change to a us. So we're going to go ahead and we're going to call this phosphorus acid. Okay? We changed the ite to an us. All right? I'm going to skip down and go to number 7. Hydrofluoric acid. The fact that I see hydro means that it's a hydrogen plus 1 element, which so happens to be fluorine. So all I'm going to need is hydrogen, because they all start with a hydrogen. And then fluoric is a fluorine. That's it. Oh, that means that number 9 is going to be easy too. It's binary because it starts with hydro. So it's a hydrogen plus 1 element off the periodic table, which is going to be HBr. That's it. Let's go ahead and go to number 8. Ooh, nitric. IC. So I need to find something that actually ends in a NO. What was it again?
NO3.
And what does NO3 end in?
NO3.
What over here? What does NO3 end in?
It ends in, nitrate.
8. I heard it. 8. Because this is an ick, then it ends in an 8 over here. Here it is. NO3 is correct, and it ends in an 8. So in this situation, H, because all acids begin with an H, NO3. Don't forget, my hydrogen has a +1 charge, and this polyatomic actually has a -1 charge. Crisscross those. That's the reason why there is no parentheses, and this H has a 1 that crossed over, and so we don't add a 1. Let's try it again. Let's go to number 10. There is no hydro, so that means that this must be a polyatomic. Let's go ahead and let's look at this. This polyatomic ends in an OUS. Because it's an OUS, when I look at the polyatomics, I'm looking for an ITE. All right. Well, I know they're all going to start with an H, but I need something that has ITE. So, what polyatomic is it with an ITE? There it is, sulfite, which is SO3 -2 charge. So hydrogen is a +1, Sulfite is a -2. When I crisscross those, it actually becomes H2SO3.
I got a question.
Yes, sir.
If the hydrogen was to say had a 3 in it, would you just cancel those two out and say it's HSO?
No. No. Because this is part of the polyatomic. You would have to look at the parentheses charge on the outside. And hydrogen is always a +1, so we'll never have parentheses.
Okay,
Mhm.
that makes sense.
Yeah. Let's go ahead and you do 11, you do 12. I'm gonna pause it and I'll write the answers. Cause I don't want y'all to be cheaters. There we go. Okay. Nitrous, SOUS. I need an ITE. So. Ick, IC. I need an ATE, which is a got it. Alrighty, I'm gonna unfreeze it, and then let me know when you're ready. Okay, sounds good. All right, I heard ready. So here is the right answers. We have two. They are going to be polyatomics because there's no hydro in the beginning. And I've got to go look at the polyatomic chart. I know all hydrogens are a +1. I had to go find the OUS, which should have ended ITE, and it was a -1 charge. Crisscrossed it, no parentheses. Come over. Yes, ma'am.
Where did you get the +1 again?
I got the +1 from the hydrogens charge.
Okay.
Mm-hmm. So again, I did the hydrogen charge, right, of a +1 because it's in group 1, but I have an IC, and when I look at IC, I need to end in an ATE on the polyatomic charge. So PO4 is actually a -3, crisscross those, the 3 goes to the hydrogen, no parentheses on the polyatomic because it's a +1 charge. Now, there's a little saying we have in chemistry. Again, I try to give you as much knowledge that I have or what keeps things straight in my head. So here, the saying, I'm going to put it over here, and you don't have to write it. You don't like it, that's completely okay. My feelings aren't hurt, but ick. Ick. I ate a poisonous bite. Okay, hold up. It's going to make sense in a moment. Ick. I see. I ate a poisonous bite. Ite. The ATE becomes an ick. The ITE becomes an us. You don't have to, if you don't like it, you don't have to write it. Ick. I ate a poisonous bite. Ate becomes an ick. Ite becomes an us. Okay? It's just a little chemistry saying, unless you're super genius and you just like are like one of those people who read it and you're like, I got it in my head. I'm not. Okay? I'm the person who has to come up with little things to remember. All right? I'm going to come over here. It says, here's a little bit of some extra practice. Okay? Now, instead of us finishing here, we can come here on Friday. I would like to go to a review of moles. And we're going to go to a review of moles because we're going to go ahead and finish our notes over in talking about what are we ending in? We are going to end in empirical molecular formulas and percent compositions, meaning we got to kind of go back to a little bit of review from moles. Now, when we did moles, we came over here with that mole chart. If you remember on the that periodic table, I added the mole chart. And the mole chart says that you've got grams, and we know from the mole chart that grams can go either way. You can either go this way or you can go this way. That's why the arrow is back and forth. But we know that now. And this grams equals 1 mole of anything. Of anything. And 1 mole of anything, again, if you're going this direction or if you're going from the right to the left, which is completely doable, equals Avogadro's number of 6.02 times 10 to the 23rd particles. Now, what particles are you talking about? We can be talking about particles which are FUNs, which are ionic compounds. We could be talking about MCs, which are molecules, but those are covalent compounds. Or we could be talking about just in general atoms, because it's just an element. How many, molecules of gold? Did you have just a solid gold necklace? We can do that. If we put that gold necklace that you have on the scale and found out the grams, we can go through this and figure out how many actual particles of gold atoms you have. Okay, now going back to this again, don't forget, we came and found this grams from the periodic chart or the periodic table, right? And what did we look at? We looked at the mass on the periodic table. So we're going to get this grams from the mass, or we also call this the molar mass. You remember that? We're going to need this information on the next page, but we're not doing the next page today. And don't forget, this is equal to 1 mole, which is equal to Avogadro's number. Now I'm going to pause for a minute, and I'm going to go ahead and pull up this mole chart. We already saw this mole chart here. It has grams, which is the molar mass from the periodic table, which equals 1 mole of anything, which this equals the number of particles, or Avogadro's number, okay? But remember how it broke down over here a little bit more? Well, we should be able to, on the next page, we're going to break it down over here. We're finally going to get to this section, okay? But as a quick review, let's go ahead and let's look at this real quick before we go any further. It says if you go to the scale and you actually weigh out this much aluminum, let's say I tell you, hey, go to the scale, get the aluminum foil, right? And I want you to weigh out 90.5 grams of aluminum foil, which is aluminum, okay? How many moles do you have here? Well, this is what I'm looking for, how many moles. Now, I started off with mass, and I'm going to get that number from the periodic table of aluminum. So let's write down what we have, 90.5 grams of Al. Kind of like math or algebra, if I want to cancel out the grams, which I do, and I want to get to moles, I need to have grams at the bottom. Well, our mole chart over here says, go to the periodic table. And remember, aluminum, which is a metal, even though he touches the stair steps in group 13, has the number of 26.98. I'm just going to leave it 98 because that too. I'm just going to go to the second digit. So 26.98. You can go to the 2 if you want to. I'll go ahead and write it down just to make whoever happy. Now, these grams cancel out. This equals, what does grams equal? I agree, 1 mole of aluminum. And I want to get to moles. I do not have to go any further. I stop. I'm going to put an equal sign. And I'm going to do the math. Everything at the top gets multiplied. Everything at the bottom gets multiplied. Then divide it. go ahead, you should get 3.34 moles of aluminum. Your SI unit is moles of aluminum. But double check me because this is last year's number. Oh, 3.35? Okay, I'm sorry. That's all right. No, I can change it. 3.35. And that 5 looks like a 5, unlike some people's 9s. Yeah, you're not. Did you hear that? Vicious. I'm proud of you. Way to speak up for you.
Nah, I'm still losing.
No. Because you're calling your family member. Ah. No, don't even touch me.
I'm wondering, so why is it measured in grams though?
That's what I
Is it? So wait, what, a mole is just one atom, wrong?
No, a mole is, remember, the word mole is like a pair of shoes. It's really 2 shoes, but we call it a pair. A dozen of eggs. It's really 12 eggs, but we call it 1 dozen. So 1 mole really is Avogadro's particles, which is also equal to the periodic table's mass.
Avogadro's number is just that many particles equals that many grams.
Yes.
Okay.
Yes. Yes.
A lot more sense.
So if I was to ask you, Daniel, I need you to bring me 1 mole of aluminum. You're going to go to the aluminum foil and you're going to rip it off and you're going to put it on the scale, which is 26.982 grams, which is equal to 1 mole, which also equals that many atoms of mole. They're all the same. 2 pairs of shoes is 4 actual shoes. Let's do 1 more and then we can call it a day. It says, all right, a party balloon contains this many atoms of helium gas. What is the mass that you have in that balloon? Question mark, grams. Mass. Okay? Now, where am I starting off at? Am I starting off on the left, the middle, or the right? The right, correct. I'm starting off in the right. Where am I going to? All the way to the left, to grams. Okay, so let's write down what we have. It's been a while since we've done this, so we need to review it. Times 10 to the 24 grams of helium. Now, just like algebra class, I need to have grams of helium down at the bottom so they can cancel out. So I'm starting. Whoa. Why did you let me do this, Acosta?
It's all your fault, Andres.
I wasn't even paying attention.
Yeah.
I was writing it down
Atoms.
You said you
Atoms.
wasn't paying attention to your.
I heard, yes, I heard that.
Wait a minute.
And don't worry about it. We've got it, Taj, we've got it recorded.
She got her mixed up. You're gonna get it.
We've got that recorded. Did you just say a bad word? Because that's being recorded too.
I said day.
And I have no problem
Oh,
videoing him.
What did I do?
Now let's come back and let's get back on task.
All I was doing was writing it down.
Oh, sounds like you're denial. Okay, so whoa, hold up. Give it to Addison. Shh, give me a second. Addison, I apologize. We are definitely at the far right, and we got to move to the left. So I have to have atoms over here. Where do I get that number from? I agree. Avogadro's number, 6.2. I agree with her 100%. 6.02 times 10 to the 23rd. And what is that equal to? 1 mole of HE. Now I get to cancel out those atoms of HE. I have a mole, and down here, is that where I want to stop at? No, I want to stop at grams. So I've got to put mole of HE down here so they can cancel. What am I going to put in front of that? In front of the mole of HE?
4.038.
1
1 mole.
equals, and I agree, the mass. And what's the mass number, Daniel? You were saying it?